Okay. All right, 6-1, day 1. This whole chapter, we're going to be finding what's called a confidence interval. I am recording right now. No.
Wait.
Watch it later. That mean was to you. Oh, I get it. You mean like punk.
Okay. You won't know what a confidence interval is until we kind of get going. Amanda, do you need something? Oh, I do. You're welcome. Okay, let's just say I was studying something like average backpack weight of the American high school student, like we talked about way at the beginning of the semester. Again, I probably can't get to everybody, so I don't know that population value. So what statistics is based on is grab a sample and let that sample represent your population. So what we're going to do today is, for a given level of confidence, we're going to find an interval that we expect the population value to fall in between. That's our goal. And it's just a step-by-step process. So the first thing we're going to be doing is finding what they call a point estimate.
I think you're like talking with a different tone right now. Like, because you're being recorded. Like it's softer or something.
She's
For
not going to yell at Lily.
for the population mean is, what would I use to estimate the population mean? Do you think? Well, standard deviation is not a good estimate for a mean.
Median?
How about the mean of the sample? Well, I would hope a mean would estimate another mean. Hopefully. So if I grab from my population, I would hopefully like to have my sample mean estimate that population mean. Do you think I'm going to get it right on the nose? No. Probably not. That's why we do an interval. Give us a bigger range to say, well, my population's probably somewhere between here and here. So we start with the point estimate for the population mean, and that is the sample mean. And then we move on to what I've been talking about. It's called an interval estimate. Is a range of values that should contain the population mean. And level of confidence. Lowercase c is the probability that the interval estimate actually contains the population value. So when statisticians do these confidence intervals, there's 3 levels of confidence that are the most common: 90%, 95, and 99%. And sometimes you'll see them displayed on TV news stories and things like that. So we're going to go over those 3, but the book, I'm going to say 90% of your problems are going to use these 3 values, and then occasionally they'll throw in an odd duck one just so you remember how to find this particular z-score for the confidence level. So the z-score for a given confidence level. So we're going to make a little table. You're either going to memorize these 3 values, keep flipping back to your notes to this page, or calculate it every single time. Confidence level. So we're going to have 3 values here: 90, 95, and 99. Inv norm. And then the actual z-score that we're going to use in our formula. And this you did on your test Friday, finding a z-score for a given area. So we're going to have our sample mean be the middle of the graph, and then we're going to make an interval around that sample mean, where that will contain either 90% of the graph, 95, or 99. So when I back up to a negative z and go forward the same amount, this middle portion then is my confidence level. So that's 90% of the graph in here. So from your last chapter, what do you feed inv norm to get this negative z-score if there's 90% in the middle? What's the left area? 5%. So we're going to do the inv norm of 0.05. That will give us this negative z-score, but the formula uses the positive one. So if you do the inv norm of 0.05, what do you get? So you get the negative, but we're going to keep the positive. 1 point what? For some reason, the book goes out 3 places on this z-score. I don't know why, but we'll just, if you want to match the answers in the book, you're going to go out 3 places here. All right, now let's switch the middle 90. Now we're going to bump it out to 95%. I'm not going to redraw a new graph. But if there's 95% in the middle, what does that leave for this tail piece? 2.5%, so you would do the inv norm of 0.025, and we want the positive equivalent to that negative one that's coming up. What do you get? So 1.96 is what the book uses. And then the third one is to have 99% in the middle. So then that leaves what in the tail piece? 0.005. And then that z-score is, and they go out 3 places on this one also. And they have 575. I don't know why they didn't make it a 6. Hunter. Never mind. Okay, like I said, about 90% of your problems are going to be one of these 3 confidence levels. So you're either going to memorize these or keep flipping back to this table or redoing a graph every single time. But every once in a while, they'll throw in something like 80% just to see if you remember this process that we used to get here. So, we're going to be doing these confidence intervals by hand with a formula, tomorrow with a program, and all the way through the whole chapter by hand, by program, by hand, by program. So this first day we do by hand one day, program the next day, and then we'll do both all the way through to the end, because you'll be familiar with the whole process. So, this is what if I was to make a note card for this test at the end of the chapter, this is what I would put on it, right here, these steps that I'm going to give you. So it's the confidence interval for the population mean, with a large sample. Large meaning hitting the magic number 30. Okay. Your first step is to calculate, if it's not given to you, like they give you a list of data, you want to calculate the sample mean and sample standard deviation. Okay. Some of the problems, they just tell you what these two things are and you move on to step 2. But if they give you a list of data, how am I going to find the mean and standard deviation? One var stats. After that, you're going to calculate what's called maximum error. What max error represents is kind of right in the name. It's the maximum amount you would have been away from the population mean, from the actual value. The farthest away you could be for that given confidence level. And it's just a simple plug and tug formula. Big E equals the z-score for your confidence level, which 9 times out of 10 is going to be one of these 3 z-scores. Multiply by the population standard deviation divided by the square root of the sample size. Now, little asterisk here, little star. If the population standard deviation is not given to you, is not known, S can be used in its place. Because these are all, when we're done, this is an estimate we're giving. And you know when you look at one var stats, that sigma and that S, they're usually fairly close to each other. So that's why we can substitute S in there, because this whole process is giving us an about interval. So we don't need to be super exact there. And then your last step is to actually write the interval. For the population mean. And to do that, you're going to take the point estimate, which is the sample mean. Then you're going to add and subtract the big E that you calculated. So you'll take the mean, subtract the error, that you take it down to a low end, and then add the error, and it gives you an interval when you're all done. Pretty easy process. So,
How many examples do we have?
just one with 2 parts.
And that's it, we're done.
Yep. And this is what I call by hand. So like I said, tomorrow we'll be doing it with a program. So, number 1. We want to construct the 90% and 95% confidence interval for the population mean for the data on page 252. So let me show you the book. Grab calculators if you don't have any yet. Okay, what we've got, I don't even know why, who would even study this? But they took a random sample of magazines and found an advertisement and then counted the number of sentences in the advertisement. I can't imagine who would care about that piece of information. How many sentences are in an advertisement in a magazine?
Somebody that's in the advertising business.
But what does it tell them? I don't even know what value that has. But anyway, that's what it is. Okay, and then here's their 30 outcomes. One advertisement had 99 sentences in it. Who's going to read 99 sentences in an advertisement? I don't know that I would. Okay, and we want to find the 90% confidence interval and the 95% confidence interval. And what we're going to be finding is, for all magazine advertisements, we're going to be able to find a range for the average number of sentences per ad. So that's important to know. So, step 1, what's the first thing I need to do here? 1 var stat so we can get our sample mean and sample standard deviation. So go ahead. Let me make those bigger.
Yeah.
There you go. Some people already started. I know, because I just have, sometimes I have a tough time with what the studies are on.
That's what we feel every day of every single class.
Oh, I don't know. I know they've got, I mean, with math, you've got to start so simple. You're thinking, who would ever do this? Just so you can learn it so that it can be applied somewhere. And with my limited amount of stats background, I don't really know where all of it's applied. I don't know.
Test tomorrow, I'm never applying that anywhere.
Oh, they were telling me the M-STEP, what it does, it kind of like, have you taken the compass test over at Bay? Where the problems start out real easy, and then as you get them correct, it gets harder, and then pretty soon I think you get kicked out. That's according to Mr. Marshall.
So if
He
you
said.
just get them all around?
I don't know. I don't know. Then you'll be labeled not college ready.
This doesn't label you on college readiness. Arithmetic says it absolutely does nothing besides grades and teaching.
It labels you. I'm not saying it's a correct label, but you'll come back with a label.
It's on your transcript, though.
Yeah.
Your M-STEP score, even though like colleges
Yeah.
don't care, it's on your transcript.
Yeah. You do with the test what you want. I encourage you to try your hardest.
After the same problems that we
Okay.
I'm not going to be able to get the easy ones. Those are the easy ones.
I don't know why. I'm hoping those ones we looked over were,
Those are the hardest.
yeah.
If not, we have a problem. All of them.
Okay, did you guys run 1 var stats?
Yeah.
All right, so we want, what 2 things do we want off of that screen?
Sample mean and sample standard.
Yes, the sample mean, what's the average number of sentences? Oh, I'm a little zoomed in. Okay, what'd you got?
12.42.
So is she correct at 12.42?
No.
Oh. 14.77?
Actually, how many data values are there?
30.
If she wasn't recording, you'd get yelled at right now.
I would not. What's the correct S then? So we don't want Lily's because that's not going to match.
16.54.
16.5. Hunter, take the correct one. Did he take the S?
Yeah.
Okay.
What are you recording?
Well, somehow I have different
Absent people.
values in here.
Because first hour, because I'm gone in the morning testing with some group, they did double notes. They did notes on 6, 1, day 1 and 2 this morning, and then tomorrow they're just going to do 2 assignments, where you're going to just get 1 day and 1 day, so. All right.
Oh.
Second step now is to calculate max error, big E. The big E formula, I'm going to write it out again because it's on my other piece of paper. The z-score times the sigma divided by the square root of the sample size. Okay. We're doing the 90% confidence level first. So the z-score for 90%, like I said,
1.645.
looking back, 91.645. Now the biggest mistake I see people make is the formula has this sigma, so people want to take sigma off of the calculator because it's there. There's a value by the sigma. But what did you type in that list? Was that a population or was that a sample? It was a sample. Remember, the calculator does both of them because it can't read the book. It doesn't know whether that was a population or a sample. You are supposed to know. So we are not going to grab the sigma off of the calculator. We're grabbing the S. And it's okay to put an S in place of a sigma if you don't know the sigma. We don't know the sigma. So 16.54. What was our sample size? How many numbers did you put in the list? 30. And then it's just calculator work from there. Nope, you can type that all in one line. And when you're ready. 4.97. Okay, now we're ready for the estimate. So to get the interval, we're going to take our sample mean and then add and subtract that big error. So the sample mean was up in step 1, 14.77. And the max error was 4.97. So subtract first, get the low end. What is it? 9.8. And then when you add, so we would expect the average for all magazine advertisements to have an average between almost 10 and 20 sentences per ad. Okay, that was the 90%. There's a lot of,
Wait, where did that,
Yeah, where did 90 go into there?
where did the 90 come into play? In the z-score right here, because this was the z-score for 90%. Lily, what was your question?
where we got the 19?
We're 14.77 plus 4.97, because you got to go through.
9.8 from?
Oh, 14.77 minus 4.97.
Oh.
You got, there's 2 problems there, and we do both of them.
Okay.
Okay? Okay. There's a lot of, not today, but tomorrow, if I switch this to 95% confidence, what do you think is going to, so what this is saying is there's still a 10% chance that I'm wrong here. 90% chance that it's in here, 10% chance that it's not. If I increase my confidence level, what do you think is going to happen to the width of this interval? You'll probably, if I want to be more accurate, I should have to encompass more numbers to catch it. So we're going to run through this. Where do I need to start my 3-step process at? At the second step. The mean and standard deviation are not going to change. Step 1's good. So all we've got to do is start at the second step, recalculate a max error. So what is the z-score for 95% this time? 1.96. And it's still that same S, 16.54, over the same sample size of 30. which is going to increase our error, which is going to increase our interval.
We have that much more notes to do.
No, this was day 2 right here. Yeah, we went right to the bell. I finished with about a minute before the bell with 2 days of notes though yesterday, or the 3rd hour. What'd you get here?
5.92.
5.92. So now our interval then, take your average of 14.77, add and subtract that new error, 5.92, to get a new interval which is going to be wider. And I'll look for an assignment for you. And when you turn this information over to whoever asked for this study, you can ask them why they wanted to know it.
What time do we leave?
Okay. Page 259, we are looking at 5.6.
Let's do other after school today.
Okay, stop.
Oh, Page.
These are long problems.
They are not.
Yes, they are. They take like half a page up.
120. There you go.
You get shot.
I need to-
I'm not kidding.